Joining us for a discussion on the recycling imperative, please welcome Chief Executive Officer and Founder at Cyclic Materials, Ahmad Ghahreman, President of Hydro Aluminum Metals USA at Norsk Hydro ASA, Duncan Pitchford, Head of Supply Chain Security at the US Department of Energy, Widad Whitman, and Senior Vice President of Strategy at Panasonic Energy, Janet Lin. Moderated by Principal at Deloitte Consulting, Ruthie Fetscher.
Good afternoon. I'm very excited to be here today to discuss recycling and urban mining as key domestic sources of supply to bolster the resilience of our critical mineral supply chains. Thank you to SAFE, and thank you to our panelists today from across industry and government for your insights and perspective. As we've discussed throughout the day, the US is keenly focused on improving our critical mineral supply chain security. And in response, industry is reshoring capabilities from across the value chain. Urban mining and recycling are emerging as strong options to create new sources of domestic supply. These options span recycling of end-of-life batteries, e-waste collection and processing, as well as industrial byproduct recycling, turning waste to value streams into meaningful sources of supply. Research and analysis shows that the US could stop importing over 25 critical minerals if just 10% of domestically available material were recovered and processed from US mining operations. So the questions today will not be focused on if we should recover and process these materials, but instead how to scale operations. With that, let's start with the big picture. Widad, this conversation has turned from a nice-to-have environmental conversation to a strategic imperative for both our government and industry. Can you describe that further?
Sure, and thank you so much for having me. Thank you to SAFE for putting on this panel of incredible experts who I'm very excited to be amongst. So as far as supply chain disruptions have exposed our over-reliance on foreign sources, particularly from China. As we mapped out our whole-of-government supply chain strategy, and we do this in close coordination with the interagency and specifically Department of War, it became clear that we have too many gaps. And so our intent is to make sure that we close those gaps.
Thank you. Many describe urban mining and recycling as some of the fastest ways to increase our domestic sources of supply. Ahmad, can you opine on this question and talk about how this is a strategic imperative for industry?
Absolutely. Great to be here and echoing again my co-panelists. This is a great event by SAFE. Thank you for that. Ahmad Ghahreman, CEO and founder of Cyclic Materials. We do recycle rare earth elements from end-of-life products. So we do actually go upstream to products that actually have magnets in them. So alongside magnets and rare earth elements, we recycle copper, aluminum, steel as well. Going one step back, basically for metals, there are two ways to have access to metals. Either you mine them or you do recycle them. And for majority of metals, we actually do recycle quite a bit of those in different sectors, from copper, aluminum, steel, nickel, cobalt, lead. But when it comes to rare earth elements specifically, we don't really recycle much of those, less than 1%. And that number is one of the challenges. On the other side, it means that majority of rare earth elements, 99% plus, comes from mining. So that immediately tells you that recycling can and should play a strong role in creating supply chain and access to those metals that we don't have access to today. The other angle to look into recycling basically is the pace to operation. Mining is important. We definitely need mining for all the metals out there. But when it comes to recycling, the timelines could be really rapid. You could start from a small project or a larger project and get to production of recycled materials within very few years. We have done it in 3 years for rare earth elements. But when it comes to mining, it's a little bit time consuming. So that timeline aspect of recycling also is quite important. I will cover other pieces later.
Great. Widad, in some cases, recycling and secondary recovery have been some of the only ways the United States has maintained any domestic production capability for certain critical minerals. How does recycling fit within DOE's broader strategy to strengthen private industry?
Yes, that's exactly right, and an underappreciated fact. So for certain critical minerals, recycling is our domestic production capability. When the DOE talks about strengthening our supply chain reliability for critical mineral and materials for private industry, recycling and secondary recovery are foundational to our strategy. To secure robust CMM supplies in the near future, we use our loan programs, our grants, and our tax incentives to help domestic recyclers scale. For example, this means working with manufacturers to design for recyclability so that scrap coming off factory floors is a clean, recoverable feedstock rather than a liability. It also means building the midstream processing infrastructure, the smelters, the refiners, and the hydromet facilities that industry needs to turn recovery material into specific or specification grade product. But none of that without feedstock. None of that would work without feedstock. And feedstock starts with collection. We have had a fragmented, inconsistent patchwork of end-of-life collection systems and no coordinated infrastructure for capturing manufacturing scrap at the regional level. You cannot finance a recycling facility without a feedstock stream that you can't depend on. So building that collection infrastructure is as strategic as building the processing capacity itself. The private sector has been very clear with us. They have told us that they will invest if there is, one, policy certainty, two, a reliable feedstock stream, and lastly, access to a processing facility. And DOE's role, my role as head of supply chain security, is to de-risk each of those.
Thank you very much. Ahmad, what end-of-life products or waste streams are the most important feedstocks for your business today? And where do those materials come from?
Feedstock is absolutely important for recycling in business. It's basically a two-end open problem to solve for a recycling business, where you get your feedstock, where you sell your products. End-of-life products is some 80% of our feedstock, and 20% is magnet production based. Now, magnet production based is clean, crystal clear, so I will put it aside. When it comes to feedstock, the variety of products that have magnet in them is just incredibly wild. It's from A to Z. It starts with your smartwatch to, hey Alexa, what's the temperature out there, with those speakers in our household, to speakers in your car, to your starter electric motor, windows up and down, seats in your car moving, all the way to washer, dryer, dishwasher, your fridge in your household, to power tools in your garage, e-bikes, e-scooters. I'm not going to bore you, I promise, but there are a few more examples that I will mention. Hybrid cars, electric cars, wind turbines, medical devices. The list really goes on, and all these products have magnets in them. So how you manage to basically create a system that can bring in these volumes of feedstock from variety of industries, from small mom and pop shops on the recycling side, all the way to big corporations that you have to receive their production rejects or whatnot. This basically is an important part of a recycling business. And for instance, just to give you an idea, in our company, we work with more than 1,500 companies on the feedstock side, majority of them based in the US. And we have exchanged with more than 600 of them money for their end-of-life products to be recycled for them. So without that feedstock figured out, recycling basically is going to be have very hard time to establish itself.
Interesting, thank you. Are these sources of supply, are these materials that have previously been recycled before, or are you tapping into these sources for the first time?
Majority of them, either we have basically put them in landfills or are exported outside US market for recycling. In many cases, we have seen that these products have gone to Asian countries mostly to be recycled, in many cases manually, to recover the copper value from them, not so much for magnet. Usually these products come with good amounts of copper, aluminum, other metals in them. To give you an idea, if you on average open up an electric motor or a 20 tons of end-of-life products that is sitting somewhere, usually on average you're ending up with 10 to 15% copper, 20 to 25, 30% aluminum, some 50%-ish, 55 steel or iron, and the balance would be plastics and magnets. Those are basically the key material that we would use to manufacture different products.
Mm-hmm. Great. And one more follow-up about this topic. How different is the supply chain for recycled rare earths than rare earths extracted from the ground? And where do those value chains converge?
So one challenge is we don't recycle a lot of rare earth magnets today on our planet. We do recycle, well, in China they do recycle waste of production. But end-of-life product, recycling of end-of-life products is not happening much. But when we do recycle rare earth metals through our initially physical plant to separate magnet from steel, and in the second step, hydrometallurgy, which is basically a fancy name for how to make metals by chemical process. When you make the metal by chemical process, now you end up with oxides, and that oxide is going to meet mined rare earth oxide in the separation step. Majority of the separation plants around the world that are operating for rare earth elements, they are designed for mined material, but the recycled material can basically meet those material for recycling. In fact, for separation process. In fact, our downstream partner would do exactly that. So our material would be mixed with mined material and then be separated and metallized, then magnet is made from it.
Okay, fantastic. Janet, we'll turn it over to you. Panasonic serves many roles across the value chain. As a potential buyer of recycled material, a source of scrap feedstock for recyclers, and manufacturer of batteries that could be recycled at the end of their life, what technological developments in this field are you most excited about?
Oh, well, thank you so much for having me. And you described very well kind of a three-way intersection, but I'm hoping over time it looks more like a rotary, just to go with the circular economy theme. But for now, I'll comment on us as a potential buyer of recycled inputs. So Panasonic, we put a target of at least 20% of recycled cathode active material into our battery. Now, obviously, those values are quite dependent upon the ability for the industry to provide that scale and also to meet the technical specifications that we require. So I'm going to touch upon the latter because it doesn't really get often discussed. So just to provide context, we provide high-performance batteries that go into high-performance products. And so whether we're powering electric vehicles that require extended range and faster charging, or to provide battery backup and peak shaving for data center applications, generally these cells need to be high energy density or high power density as well. And generally they require cathode active materials that do have higher nickel content. And so our active partnerships tend to be in hydrometallurgy. And so generally, so for example, if cathode active material is nominally battery grade, still we need a multi-year qualification process with any new supplier or any new supply, simply because the technology parameters are so stringent. So if you have even trace levels of impurities or contaminants, that really does affects the battery cell performance as well as the battery cell safety. So we're excited, and we continue to work with our partners to develop or co-design a recycled cathode active material and be able to show what it really looks like to be able to remanufacture material and have that go back into our manufacturing process. So that's midterm. Long term, excited about the general movement towards a closed loop manufacturing process, particularly direct recycling, that could be a part of an integral production process step for us. So being able to, for example, redesign a battery with recyclability elements into it. So recycling is not just an end-of-life step, but it's also a key step in terms of being able to feed to the upstream battery materials feedstock. And so particularly in my role in the organization, I had strategy as well as sustainability. Sometimes the objectives are melded together, sometimes they're evaluated side by side. But generally, what I'm most excited about, and also what requires the most innovation, is to find the ways to improve the unit economics, because that's really what's necessary in order for us to cement our leadership from a technology and a manufacturing perspective, particularly in the United States.
Thank you. Where do you see any gaps, either from a technology or policy perspective?
That's a great question. But first, I'm going to talk a little bit about the opportunity before I get into to some of the challenges there. So since early 2010, our battery cells have been cycling across many roads in America. We've got about 19 billion cells that are supplied to over 3.7 million electric vehicles. Actually, I think that statistic is pretty outdated at this point, but still, the general trend is that the aging electric vehicle fleet with return batteries are coming back, and then that market is exponentially growing. And so in order to be able to handle all of that incoming feedstock, we certainly need a efficient and economic collection, logistics, and processing infrastructure here in the US. And what I would say is that, particularly for the collection part of the equation, we certainly need a more less fragmented, and it's built in parts, but not really at a national level. And so, and one of the reasons why, particularly in the EV battery space, is that it's being managed, or the logistics are being managed by EV OEMs. And so I think we really need to achieve a more efficient and national standard with regards to reverse logistics network to be able to serve what we think should be a critical asset to the United States.
Thank you very much. Duncan, when the average person thinks about aluminum recycling, the first thing that comes to mind is a beverage can. There is an impression that aluminum recycling is less suitable for high-performance strategic applications. How would you push back on that perception with the work you're doing?
Yeah, and I think one term that's been used up here on the stage is sort of emblematic of that, and that's secondary. People hear secondary and they think inferior, and it's not. It's just a different process of producing the material. As mentioned earlier, there's two ways to get metal. You can mine it out of the ground, and you can recycle what we already have. And what we see is increasingly, particularly with aluminum, we can recycle aluminum that we have and use that in a lot of safety critical applications. You know, our company has been producing bumper beams for cars, for example, which is a very safety critical application, for over 25 years from recycling. And that's just the tip of the iceberg of the opportunity space when you have uses for recycled aluminum. When we're talking about energy and national security, there are two wins that you get with recycled aluminum. One, it's already here. It doesn't have to be put on a boat. We're not trying to get it out of the ground in some place that may or may not be aligned with our national security values. And from an energy standpoint, we're using 5% of the energy that we would use to produce primary aluminum. So you get a double win when you're talking about energy and national security. And we can do 95% of the applications from recycling that we can do from primary.
That's fantastic. What does it take to fully make a closed-loop aluminum recycling network work for higher specification applications spanning national security, aerospace, et cetera?
Like many complex problems, unfortunately, it has a bit of a complex solution. But it starts on the drawing board. We have to design for recycling. And design for recycling means not just that we think about how we're going to process this material at the end of its life. We also set the specifications in such a way that you can use recycled material. 25 or 30 years ago in our industry, there was a belief and a perception that you couldn't use recycled material. And so specifications were written, no recycled material. And so the opportunity wasn't even there. We know now, again, most applications you can use recycled material. So it starts there. And then it is some of the other things that we've been talking about here on the stage. It's getting the collection system built so that we get the material back in the loop so the industry can process that material effectively and reuse it in new applications.
Fantastic. You know, you're hitting on a lot of the themes we've discussed today, both the importance of feedstock and also the importance of designing with that secondary use in mind. One other question I have for you, Duncan, is Hydro has successfully scaled a battery recycling facility in Europe. What were a couple of the lessons learned that you have that could help us scale here in the United States?
Yeah, so we have the Hydrovolt recycling facility in Norway, which is one of the largest battery recycling facilities in Europe. And I think a couple of things to keep in mind when you're launching into recycling something that didn't exist 15 years ago, right? Large amounts of battery electric vehicles didn't exist. One is patience. It takes time. It's new. It's different. It's a technological challenge to be cracked. And the second thing that I would say from that adventure that we have been on is you need partners along the way. You need to know that there's going to be an offtake for that material, and you need to know that you have the specifications aligned so that that offtake can be taken when you launch into that venture. We know a lot more now than we did 5 years ago, and we see a bright future for battery recycling in Europe and in the US, because again, it meets a lot of needs that we recognize in this room. You got the material here. Let's find a way to effectively reuse it.
Mm-hmm. Ahmad, on that note, I'm going to turn it back to you to think about how we can use lessons learned from overseas domestically. Your business model involves creating a domestic supply chain for materials that are processed overseas overwhelmingly. What are some of the biggest technical or logistical hurdles you've had to overcome to make processing possible on US soil? And what have you learned across industry to make us successful here domestically?
Great question. So again, this basically ties up to a good extent to the feedstock, how you collect that for the business, and how you operate a recycling business. Within our business, basically, we broke down the business into two pieces. One of them we call spoke, the other one we call hub. In spoke, with physical process, basically with physics only, we bring in end-of-life products and we recycle those. So these unit operations could be very close to collection points of where the end-of-life products are available. So basically, we can go close to where the end-of-life products are available, so we optimize for shipping and handling cost from that perspective. And then we separate the magnets from, which is the product we produce is in the 5% of the total mass coming into our spoke. And only the magnet piece goes to our chemical plant, which is one central operation in the US in South Carolina. So that has been a model, a business model to enable us to optimize our logistics costs and be able to develop this business. We actually built the very first commercial plant of spoke in Mesa, Arizona, and we have really great updates on that and soon to be operational in in very few months. We will have more updates on that very, very soon, in a couple of days or so. So that plant is going to be bringing in 25,000 tons per year of end-of-life products that have magnet in them. And then copper, aluminum, steel from that plant could be locally marketed and sold in local markets, and magnet from there could go to our second unit operation for processing. And this is how we envision to expand in different jurisdictions as well. We announced a project in South Carolina to cover southeast of the US, and soon we will have another project in US as well. And this is basically enabling us to tackle the logistics costs for the business.
Thank you. A quick follow-up, what conditions need to be in place to further scale the circular economy and downstream manufacturing in the US? And how should industry, including OEMs, balance pragmatism with longer-term competitiveness?
So, majority of the products we collect in the market in the US today, our biggest competition is China, actually. So those products are shipped to Asia, the magnets are manually removed in some cases and moved to China. So that's one of the competition we have in the market within US market as well. So that's something to be addressed and discussed openly about it, that this is a challenge. We should be able to address this challenge and discuss it. Other than that, really, it is on us, on the corporations, on the companies itself to build a stable business. After all, this is, as Duncan alluded to it, this is building a supply chain for the very first time in North America, in Europe, in ex-China. The recycling industry for magnets does not exist. So we are really break by break, step by step. We are building the supply chain. We are putting down the tracks for recycling of magnets and rare earth elements. So closely working with OEMs, with different parties and partners in the industry, just to make sure that not only they think about the unit economics, which recycling should be able to compete with mining sources of critical metals, period. But also for access to these metals, because end-of-life products with magnets are already in the US. So we are recycling those products and putting those back into the economy. If I go a little bit deeper on this, the rare earth elements we recycle, majority of them are neodymium, praseodymium, dysprosium, terbium, and samarium. And I'm going to quiz everyone on those names after this panel. Not all the rare earths are made equal. Neodymium, praseodymium, or light rare earths, those are 70% mined in China, 30% mined outside China, within US, within Australia, other countries. But when it comes to heavy rare earth metals, which are actually the more important ones, those are 99% plus mined in China. Now, recycling, because throughout past 10, 20 years, and as a recycling company, we lived 10 years ago. We recycled the products that were produced 10 years ago. Those products actually do have those heavy rare earth elements in them. And we can recycle and be the second resilient source of those heavy rare earth elements in the market. So that strategic thinking is something that a lot of industry and OEMs do have now, and they're looking at the problem the right way, I would say.
Okay, thank you. So we spent a lot of time on technological feasibility as well as the importance of creating this domestic source of supply. And so now I want to move on to the policy side of this conversation. Export restrictions are proposed as a policy lever to retain the feedstock domestically or prevent adversaries from overbidding on scrap material. SAFE is working on writing an issue brief on the economics, impacts, and trade-offs of export bans. Where can export restrictions help, and where does this tool do more harm than good? Duncan, I'll start with you.
Yeah, you know, the 800-pound gorilla in our business, in the aluminum business, is China. And what we saw in primary aluminum production in the year 2000, primary production in the United States and in China were roughly the same, 4 million tons a year. Today, China's 45 million tons a year, and we're less than 1. But that didn't happen by accident. That happened because the Chinese government took policy decisions, non-economic policy decisions, to support that production. What we see now is the Chinese government has said, okay, we've got the primary we need, now we're going to get the recycling we need. And they have a target to add about 10 million metric tons of recycling-based aluminum production over the next 5 years. In the United States, that would be 3x the size of our market. China doesn't have that scrap today. Their economy hasn't reached the level of maturity and turnover in aluminum-intensive products to generate the scrap needed to feed that capacity. So they're going to come looking for it. We see that happening in Europe today. You know, Hydro is the largest aluminum producer in Europe. We're quite active in that market, and we see non-economic exports of scrap from Europe towards Southeast Asia. If we aren't careful in the United States, we could face the same challenge. And that's where policy solutions are unfortunately necessary, because we have non-economic behavior occurring in the market. Aluminum scrap is a national security asset, right? When you think about aluminum in our business, we talk about it as congealed electricity because of the amount of power that was needed to originally produce that aluminum. That's a national security asset for us to use here in the US, yet we're exporting 2 million tons a year of scrap overseas. And what we see now is, unfortunately, that is starting to leave for non-economic reasons. Therefore, for the scraps that we can use here today in the United States, we need policy action to make sure that those stay here at home.
Thank you. Janet, Ahmad, anything to add?
Maybe a couple of words on this one. I will add that on our website, for every 10 clicks we get, 6 of them are from China. So that tells you something. So rare earth elements market is extremely tied to China. So establishing the industry outside China, I used to say takes a village, and I'm going to say it takes whole North America now to build it. It takes everyone to support this industry, to create it. In some cases, we have seen that Chinese buyers of end-of-life products with magnets are bidding on those products for more than contained metal value of those products. If there is $100 worth of metal in this product, they are bidding on it for more than $100. And that's basically, in some cases, what we see in the market today, and just wanted to point that out.
Thank you.
So export restrictions on battery scrap production isn't going to necessarily change our operating model there. All of our battery scrap from our production stays domestic. And so, for example, in the Nevada Gigafactory, our battery scrap travels just several miles down the road to the facility managed by Redwood Materials. I suppose where the core issue around this is really around processed black mass. And even if it is well defined or narrowly scoped towards that, still, I would say that it still goes a bit ahead of where I think the core issue is, which is that there's not enough U.S. processing capacity. And so, for example, one of the reasons why there's such a strong economic pull from China is because they do have the well-developed and larger refining capacity. And so they do have those they do have the ability, that infrastructure to be able to process those large volumes. And so I think, key is really around the sequencing piece. We first really need to stand up the US processing industry. And in that regard, we, for example, wouldn't want to see black mass material that's piling up at collection sites where the recyclers are unable to process that material. It becomes a safety and it could be a cost issue. We also don't really want to see recyclers be left with unused refined material, even just in case that doesn't achieve battery grade or the battery specifications, and then they'd be left with a devalued material that doesn't have a domestic buyer. So I think it's just important in this rather early industry that we be able to stand it up and be able to signal a very strong demand to be able to address this very important midstream of these critical minerals.
Thank you. Great points brought up by each of you. I appreciate it. Widad, I want to turn it over to you to wrap us up. We've talked about export restrictions and we've talked about other policy levers throughout our conversation. But what other policy incentives may bolster this emerging industry?
Yes, so I had mentioned grants, loans, tax credits. One of the areas that is not necessarily as public is also our Secretary's designation authority. So the Secretary of Energy does have the authority to designate companies as FEOCs, or foreign entities of concern, in coordination with the Department of War and the Office of the Director of National Intelligence. And so again, by leveraging all of the tools in the tool chest, both within the Department of Energy, as well as in coordination with the interagency, so Commerce with and other offices with sanctions and 1260H list, to really be able to move the needle as much as we possibly can. So,
Great. Well, thank you all for sharing your insights today on this important topic. Please join me in giving our panelists a round of applause.